For this video, I'm going to show you how to address your inputs and outputs. First, you're going to go to your PLC. Under the PLC folder, click on Device Configuration, and it's going to open this window. If you zoom in to about 400% and scroll over to your PLC, on the input and output modules, you're going to be able to see the specific addresses that they have. So for the input module, you can see DI 0.1 through 0.7. That's your first input byte. And on the output side, DQ 0.1 to 0.7, that's your first output byte. You have more bytes. This is your byte 1, this is your second byte, third and fourth byte. You don't have to use all of them. This is just where you can check how many you have and what the address is. Now, when you're creating your program, you want to know exactly what your inputs mean. So that means tagging your inputs and your outputs. So in this example, I'm going to show you how you do that by going into the PLC tags folder and clicking on default tag table. This is going to bring up your default tag table. It might have something. It'll probably be blank. So let's do that. If you when you want to add a new tag, you have to click on the address, and there's two ways to do this. You can either type it in yourself, I0.0, and it's going to name it tag 3. It's automatically type boolean, which is what you want. Or if you minimize your window, you can also drag your input from there into your PLC tag. So if I drag 0.2 into here, into this address, you can see it right there. It also creates a tag for it right there. Now when you name a tag and you look in your device view, you can see that that name shows up instead of the address. This is so you know exactly which one is where. Now let's name them so they have meaningful titles. So for 0.0, let's name it switch 1. 0.1 is going to be switch 2. And 0.2 is switch 3. For your outputs, let's bring in output 0.0 and 0.1. And name these guys LED 1 and 2. Now, how do you use these tags? When you go to your program in main OB1, I've already got a normally open contact, so up here you could either add I0.0, and it's going to show switch 1 automatically, or you can type in the name. So LED 1, it's going to give you a drop down to tell you that it recognizes it. You can just click enter and it will assign it. Now let's look at our simulation again. Before I do the simulation, let's create a latch circuit. So for a latch circuit, we're going to create another branch in your network. You do that by clicking on the open branch at the top and dragging it down onto your power line, which is on the left. Let's bring another open switch. And then let's close the branch by bringing in the closed branch from the top. I'm going to add switch 2 after the branch. We'll see this later. And to the other branch, the second branch, I'm going to add LED 1 again. What this is going to do is tie the output into the input. So when the LED turns on, the power can flow either through switch 1, or if that's turned off, it can flow through LED 1 because this contact is going to be closed. So let's download this to our device. just right click, download to device, click on load, and it will automatically begin monitoring. If it doesn't, you can just click on the top right to see that. We bring up our simulation. When I click on input byte 0.0, it's going to close that contact. It's going to close that contact, and its power is going to flow through to LED 1 as long as switch 1 and switch 2 are closed. So switch 1 right there, you can see power flowing through. It doesn't go through switch 2 because that's open right now. Let's close that. Power is not flowing all the way through to the LED, and you can see that it's also flowing through the second branch. So now, by the way, if you want to see where the LED output is, it's right there in QB 0.0. Now if I turn off switch 1, even though power is not flowing through this branch, it is flowing through the second branch because it's tied to this. So this output is setting Q 0.0 to a boolean of 1, which closes this normally open contact. So now it's keeping itself open. Now how do you turn it off? You're gonna have to open this switch, which is why it was after the branch. That disconnects power from the output coil, and now your normally open contact that was tied to your output is also open, and both of these branches are now disconnected. So now if I turn on switch 1 again and switch 2, you get back to your normal condition. Now notice in this case, there are two ways for power to flow there. It can either flow through switch 1 and switch 2, or it always has to flow through switch 2, but it can either flow through switch 1 or LED 1, in this case tied to the output. These are two types of logical arguments. The parallel branches are known as an OR branch because the power can flow through one or the other. On the horizontal, switch 1 and 2, the power has to flow through both of them to get to the AND, so this is known as an AND. Using a combination of these, you can increase the complexity of your code and set certain conditions to activate your output.